Let's talk about propellers. Oh no, Horsey, fly away! Shh! A couple things that I want to make sure you are aware of is the definitions for propellers. One is diameter, pretty obvious, so make sure you draw a little picture of that. The other one is pitch. Pitch is how far forward the propeller goes in one rotation. Good luck drawing this one. How do I do it? You might want to just draw it from like a side perspective where you can show like a propeller and then just write one rotation forward, and that's the pitch. So pitch is measured in inches. It's how far forward, again, it goes in one perfect revolution. So that's as if it were like digging through jello. You know how you take propellers and you dig them through jello? That's exactly what it's like. So a 6x4 prop is a 6-inch diameter prop, and the prop moves at an angle such as during one rotation it moves 4 inches forward. So make sure you know that 6x4 means 6 is the diameter, 4 is the pitch. Which propeller would push with a greater force, the 8x6 or the 8x3? Please answer that now. Well, in this particular case, the 8x6 has a 6-inch forward. The 3 is a 3-inch forward. So that one actually does push forward at a greater force. And that is this propeller right here. I know you can't really see him with the camera view, but that's fine. That's the 8x6. What about a 6x4 versus an 8x4? What's the difference between them? Which one would have a steeper pitch? The 6x4 or the 8x4? Did you think about that one? So if you're looking at a 6x4 and 8x4, one has a slightly greater diameter, but they each go forward 4 inches. So if it has a slightly greater diameter and it goes forward 4 inches versus a smaller diameter with 4 inches, this would have to have a greater pitch, the 6x4, for it to be able to go forward the same amount. So let's take a look now at blade design and efficiency. The goal is to maximize thrust while minimizing drag through precise blade geometry. Mr. Thomas, there's a lot on this slide. But let's explain this. You don't have to write this stuff down. I just want to explain what's going on with this. So let's look at the geometry of the propeller blade. The circumference equals pi times d. So for a 6-inch prop, which this is exactly a 6-inch prop right here, it's 6 times 3.14. So the distance that this blade travels around is 18.84 inches. And that makes it move forward 4 inches if it's a 6x4. So if we look at the tip of the propeller blade, this tip right here at the edge, in order to make that happen, the angle for that is exactly 12 degrees. Well, if the middle of the blade is 3 inches from the center, then its angle, it's only traveling, a circumference of, something that's a little bit less, right? If it's pi times d, it's going to be half the amount, so 9.4, something like that. It's going to be its circumference. So if we use the inverse tangent to figure out, well, what does that angle have to be for that? It turns out that it's a steeper angle. It's 23 degrees. And you can do a little trig to solve that. But when we look at the propeller pitch, again, you're not going to be able to see it very well, but there's a twist in the propeller blade. So the propeller blade has to be a little bit less steep of a pitch on the edge and more steep in the middle. And that has to happen because the middle is not moving as fast as the tip is moving. So you have to have the same amount of thrust. If the outside is moving faster, the pitch is going to be less. If the inside is moving slower, the pitch has to be more, until you get to the very center. And that's always where there's a little bit of a taper, and eventually you get no thrust in the very middle of it because that's kind of your connection point. So you can see a little bit better when I hold it like this, what the pitch, that the pitch changes throughout it. That is true for every propeller blade. Here's another one that shows you an increase in pitch as you get towards the middle of the blade. So do prop designers want air to go straight back? Well, mostly prop designers can focus air towards the center of the prop by adjusting the angle ever so slightly so that you're pushing more air from the outside edges and a little bit less air in the middle, and that then focuses the air like a nozzle. If the outside air is moving slightly faster than the inside air, it's going to be focused. So that's one thing that prop designers can do to sort of focus air. So next question, can you have infinite thrust? If you make the pitch so big, would you have an infinite amount of thrust if that pitch number was huge? What is the ideal pitch? Well, clearly you can't have infinite thrust because eventually, if you twist these propeller blades enough, they're going to be completely perpendicular and they're just going to be pushing air out. They're not going to be pushing any air backwards. So how does that work? Well, I found someone who did a little experiment on the limit of pitch, why more isn't always better. So which prop pitch gives you the most thrust? With a low prop pitch, you get really high RPMs because there's no drag. So that would be a propeller pitch that's basically knifing into the air. There's virtually no drag whatsoever, but you also get hardly any thrust. With a higher pitch, your RPM drops because you're pushing more air behind you. So it gets really, really difficult to push air backwards. And so RPM drops. So it can be a little bit misleading. We don't always compare them to RPM. That's rotations per minute or revolutions per minute. A higher pitch prop draws increasingly more current or more energy from the engine, and that absorbs some of the power, which doesn't increase performance. So according to this little graph right here, we can see this is a 6-inch propeller. It tells us right here it's a 6-inch propeller, that if you have a pitch of 1, this is a 6x1, then we get a low thrust. This is thrust in ounces, okay? We get a low thrust, but the propeller prop is spinning very, very fast. Well, as I increase the pitch now to a 6x2, a 6x3, then the RPM drops a lot because it's trying to push more air. And there reaches a maximum amount, which is a pitch of about 50 to 60% of the diameter. So if we get a propeller pitch of 3 inches when the diameter is 6, that's about ideal. 3 to 3.5 works pretty effectively. That's your most efficient. So the rule of thumb here is for maximum thrust, find a pitch that is approximately 50 to 60% of the diameter, and that's going to give you the most efficient thrust or maximum thrust per RPM. Last thing I want you to know here is propeller type. So it's fixed and variable. A fixed propeller pitch is one that is made in one piece. That is like this propeller here, the ones that you're going to be doing and using. It's one pitch. You can't change anything. It's made out of solid wood, solid metal. It's always the same. So a fixed propeller pitch, fine. That's can be potentially useful, but it's not very efficient because if you're trying to take off, you want a very fine propeller pitch where the propeller looks something like this. And that allows you to have super high RPM like we talked about in the last slide. So the propeller can move very fast and it gets you just barely moving when you're stopped. So it kind of gets you going. But as you're moving forward, you can bite more air. And if you want to bite off more air because you're moving forward, you might want to control the pitch and make the pitch a little bit steeper. So that is why a variable propeller can be useful. So for example, in takeoffs, you might want a little bit finer pitch, and when you're cruising you might want a little bit coarser or higher pitch. So that's why a fixed pitch propeller is sort of a compromise. They might do something in between the two. So for your variable pitch propellers, there are 3 different options here. You can have an adjustable pitch where you can adjust it on the ground, and you might make it for whatever the specific flight conditions are. A controllable pitch, the pilot adjusts it in flight. And a constant speed one, there's a hydraulic mechanism that tries to maximize your RPMs in your engine to give you the most power regardless of the action and speed of the aircraft. So as far as writing down notes, you just need to know that these are the 3 different ones and then roughly sort of how these are changed. If you need to pause this to write that down, please do so. That is all that you need for this particular presentation. Now we move on to the next thing.